the properties and applications of the electromagnetic spectrum. Welcome everyone, my name is Tasneema Begum and today I will be presenting on the properties and applications of the electromagnetic spectrum. This topic explores a range of electromagnetic waves, their physical properties and how they are applied in medicine and crime scene investigation. I will also discuss the biological hazards of certain types of radiation. So this is just an overview on the presentation. So this presentation is structured to first explain what electromagnetic waves are and their key physical properties. Then I'll cover specific types of such as microwaves, infrared and X-rays, followed by a comparison between visible and ultraviolet light. After that, I'll apply this understanding to crime scene investigation before concluding with a discussion of potential biohazards and safety considerations. So, what are electromagnetic waves? Electromagnetic waves consist of electric magnetic fields oscillating at right angles to each other and to the direction of travel. They are transverse waves, meaning their vibrations occur perpendicular to the direction of propagation. Unlike sound, they don't require a medium and can travel through a vacuum such as space. All EM waves move at the speed of light in a vacuum, but they vary greatly in wavelength and frequency, which determines their energy and applications. So, key properties of electromagnetic waves. Every electromagnetic wave can be described by energy. The wavelength is the distance between consecutive peaks of the wave, while frequency measures how many wave cycles pass a point per second. Energy is directly proportional to frequency following the equation E equals h times f, where Planck's constant. This means the higher frequency waves like gamma rays carry more energy than lower frequency waves like radio waves. Microwaves, their properties and uses. Microwaves have lengths ranging from 1 millimeter to about 30 centimeters. Their ability to make water molecules vibrate make them useful in heating food, which is the principle behind microwave ovens. In technology, they are used for radar systems to detect aircraft and for satellite communications because they can pass through the atmospheres with minimal interference. So, infrared radiation lies just beyond visible red light and is mainly associated with heat. All objects emit infrared radiation depending on their temperature. Infrared is used in devices such as remote controls, thermal imaging cameras, and night vision equipment. In forensic, thermal imaging helps detect recent human activity by revealing heat patterns left behind. So, X-rays in medicine. X-rays are among the most widely used forms of radiation in medicine. Their high energy allows them to penetrate soft tissues while being absorbed by denser materials like bone, creating contrast images the doctors can analyze. They are used for diagnosing fractures, chest infections, and dental assessments. In oncology, controlled X-ray beams are used in radiotherapy to destroy cancer cells. However, prolonged exposure can damage healthy cells, so protective lead aprons can be used to limit unnecessary exposure. Visible light is a proportion of the electromagnetic spectrum that humans can see, ranging from red to violet. Ultraviolet, on the other hand, has shorter wavelengths and higher energy, although invisible. UV light is powerful and used in sterilization processes to kill bacteria and viruses. In forensic science, it is used to reveal substances invisible to the naked eye, such as bodily fluids, or trace evidence that fluorescences under UV illumination. In forensic investigations, both visible and ultraviolet light play key roles. Visible light is used for photography and detailed recording of physical evidence. Ultraviolet light helps reveal evidence that is visible under normal conditions, such as bodily fluids, fibers, and fingerprints. Investigators use UV lamps, such as fluorescent powders, to make materials glow, making it easier to collect crucial evidence at a crime scene. So, although useful, both ultraviolet and infrared radiation can pose health risks. Ultraviolet radiation can cause skin burns, premature aging, and even DNA mutations, leading to skin cancer. It can also harm the eyes, using photokeratitis or cataracts. Infrared radiation, while less energetic, can cause burns, under eye damage due to prolonged heat exposure. Safety measures include wearing protective goggles, covering exposed skin, and limiting exposure time. To summarize, electromagnetic waves are fundamental to many aspects of modern science and technology. Understanding their properties allows them to use safely and effectively in fields like healthcare and forensic science. Each part of the spectrum, from microwaves to X-rays, has its own applications, benefits, and associated links. These sources provide the theoretical foundation and factual support for this presentation. Each has been cited using the Harvard References format as required by academic standards.